All right, Precalc, so there is this awesome way to do what we call back substitution. We are in lesson 7.3, and we have moved from just an xy to now an xy and z. Our essential question is, how do you solve systems of linear equations with more than 2 variables? So now we're working with 3 variables, so we will have an x answer, a y answer, and a z answer. Back substitution's user-friendly because, as you notice, they already give us the z. So I can put that 2 in right here in my answer. And I'm just going to plug it in for this z right here. That z kind of looks like it. When I do that, I get y plus 8 equals 7. And when I solve, I get y equals -1. And now I can plug that in, and we get x minus 2 times -1 plus 3 times 2 is equal to 9. And that's x plus 2 plus 6 equals 9. Well, x plus 8 equals 9. Obviously, x is equal to 1. So notice now we're going to have 3 solutions, an x, a y, and a z. And this is called back substitution. So make sure you know this is called back substitution. We're going to learn a ton of different ways of how to do this. Things start getting a little bit trickier when we move into Gaussian elimination. So Gauss, as you notice, we no longer just have z equals. Gaussian made up this way that we can eliminate. So what he says is, hey, I can put these two together. And notice when I do that, I could eliminate these y's. And when I add down, I'm going to get 3x, those y's cancel out, plus 2z is equal to 9. And he says, look, I can even put these together. So again, these would cancel out. And when I add, I get 5x. Oh, these cancel out as well. Is equal to 5. Well, this is nice. We can solve. X is equal to 1. Now I need my y and my z. So I can plug this x in to here, and now from here I'm going to use that back substitution. 3 times 1 plus 2 times what gives me 9. 3 plus 2z equals 9. 2z equals 6. And z is equal to 3. Don't forget to put it in the right spot. And now I could just choose one of these, and I could put in all my numbers that I have. I have 1 plus y plus 3 equals 6. Y plus 4 gives me 6, so y has to equal 2. And again, this is called Gaussian elimination. So in the top 2, we're going to eliminate an x, a y, or a z. In the next 2, we're going to eliminate the same. So I chose y. And then we can go work backwards like we did. So let's try one more Gaussian elimination. This one is not as user-friendly, but we can figure this one out. So let's work together and let's figure this out. When I look at this, what do you guys think? I probably would multiply all of this through by 2. So I have 3x minus 2y plus 4z equals 1. And 2x plus 2y minus, ooh, yeah, that works out well, minus 4z equals 6. So when I continue on this road, notice that my 2y's can cancel out. Ooh, my 4z's also cancel out. And it looks like I get 5x is equal to 7. And I know some of you are thinking, really? You're going to give me fractions? Yes, you are in Precalc honors. You can do this. All right, so let's figure out the second half. I'm going to do the second half in pink. Well, I guess if I have 7, well, let's figure out the second half. I eliminated the y's, so let's continue by eliminating the y's. So instead of this 2, I'm now going to go ahead and multiply everything through by 3. So on the top, I have 3x plus 3y minus 6z equals 9. And on the bottom, I have 2x minus 3y plus 6z equals 8. And when I eliminate, look, it cancels out again, and I get 5x is equal to 17, x equals to 17 over 5. Well, that doesn't work out because I have 2 different solutions. So I would start having a red flag here if I were you, which I'm sure you do. But you could try to eliminate the x's, you could try to eliminate the z's, see if you could find something else out. But if you notice this, this is called inconsistent, and we will call this no solution. So notice these get a little bit harder. Remember, all solutions, if it would work out perfectly and it would be the exact same thing and everything cancels out, everything is 0 equals 0 or 3 equals 3. But because this one is totally inconsistent, we would call this no solution. So that is back substitution and Gaussian elimination.